Hello, and welcome back. So previously we have discussed dilations and we have discussed using proportional relationships so that you can find missing measures of certain triangles using their corresponding sides. So we're actually going to talk now about proving that figures are similar using transformations. So before, in the previous unit, we were talking about using transformations to prove that two figures are congruent. And if they were congruent, that meant they were the same size and they were the same shape. Both of those were true. In a similarity transformation, a transformation is going to happen where the image can be mapped to a new image that has the same shape, but it does not have the same size. They can be similar and not be the exact same size. They just need to be the same shape. So we're saying that these two figures here in this picture are similar if they can be it can be shown that one can be transformed to the other using a series of reflections, translations, rotations, or dilations. This is different from them being congruent, because if they were congruent, it had to be a series of rigid motions, which means that it couldn't change the size or the shape in order for them to be congruent. This is different now with similarity because you can use dilations because they don't have to be rigid motions in order to be similar. So we're going to say we can use rigid and non-rigid motions here. To determine similarity. Okay, so let's look at this. So these two we're already saying are similar, which means that some sort of transformation or combination of transformations has happened in order for this to in order for these two triangles to be similar. So we're going to start off with saying if ABC is translated, so we're trying to get this figure to this figure. So translation, we remember we're just moving the figure. So if it is translated so many units up or down, so how many units will we need to go up in order to get the corresponding points to be onto one another? So let's just say A, okay? So we're trying to get point A to point W. So 1, 2, 3. We went 3 units up. And 1, 2 units to the right. Okay? To get that to be on its corresponding point, which is W. But then once we get there, we're going to have to enlarge the object. Okay? So how much do we need to enlarge it by? That is what our scale factor is, and we learned that in the dilations video. So one thing that I'm going to look at is I'm going to look for my flattest side, because it's a lot harder to find the distance between these 2 points than it is to find the distance between these 2 points. Okay, so I'm going to look at AB. So I know that it is 1, 2, 3. Okay. And then let's look at the other one, the other side that is corresponding on the larger triangle, which is WX. And that one's going to be 1, 2, 3, 4, 5, 6. Okay. So what did I multiply to 3 to get 6? That is your scale factor. So we multiplied 2 to get 6. So 2 is our scale factor. Now, the thing about a scale factor that we talked about in the dilations video is the scale factor has to apply to every side in order for it to be a dilation, okay? So it would have to enlarge by every side. And you may already notice that that is true in this case. So the scale factor is 2. Okay? So let's complete this transformation in order to determine that the rectangle ABCD is similar to rectangle STUV. Okay, so we're going to start by reflecting it across the y-axis. I apologize for that bell in the background. Okay, we will reflect it over the y-axis. So when we reflect it, we will now have it, it's now going to look like this. So then we're going to have to move it a little bit to get it to where we want it to be, and then dilate it. So again, once we have it here, we want to get our corresponding points to the right location. So B prime is now going to need to be where T is. So how are we going to get B prime to T? So we're going to go down 2 units. Then we're going to go left 1 unit. Okay, and then it will be at its corresponding point. So now we have reflected over the y-axis, we've translated it, but now we've got to enlarge it. Okay, so now we're going to dilate it, and let's see how much we're going to dilate it. So let's start with the corresponding side, AB, and TS. How much larger is TS than AB? AB is 2 units, TS is 4 units. So what do we multiply to AB to get TS? You might be saying 2. So that means the scale factor is going to be 2. The scale factor in this case, yes, has been 2, but it will not always be 2. Sometimes it may be 3. Sometimes it may be a fraction. If it is a fraction, that means that it's getting smaller. It's going from a larger object to a smaller object. So keep that in mind. So now, instead, let's draw it on the coordinate plane after a few transformations. So we're starting with FGH, and we're going to translate it 3 units down and 2 units left. Let's start with point F, and let's translate it 3 units down and 2 units to the left. So 3 units down and 2 units to the left. Okay, so this is our new point. So now let's do, and that is F prime. Okay, now let's try H. So now H is going to go three units down and 2 units left. So 1, 2, 3 units down and 2 units left. So now this is H prime. And lastly, we have G. So let's translate G the same way. 3 units down, 2 units left. Now this is G prime. These are all transformations that we've done before. So now we have our new figure after it's been translated. Okay, so this is our translated image. So we've done that. Now we're going to need to rotate it counterclockwise 90 degrees. If you remember our coordinate rule for rotating counterclockwise 90 degrees, we went from X, Y, to negative Y, X. Okay? So for this, I'm actually going to select the points that I have. So for F prime, my point is at -1, 0. For H prime, it is at -1, 1. And for G prime, my point is at 1, 0. Okay, so this is my X and my Y, and I'm going to rotate it counterclockwise 90 degrees, and it's now going to be negative yx. So whatever y is now going to become negative, or the opposite of what it is. So it's 0, so you can't make 0 negative, so it's going to stay as 0. And now my x is going to go where my y value was, so it's now going to be 0, negative 1. So I did that for f prime, and that's going to be my f double prime. Then h prime is going to be negative 1, 1, so now we need to make that negative y, so it's going to be negative 1, and x is going to stay the same, but in the y position. So that is h double prime. And now g, same thing, 0 you cannot make negative, but now it's going to be 0, and then x is going to be where the y value is. So it's going to be 1, 0, 1, and that's going to be g double prime. So these are going to be our new points after it's been rotated 90 degrees counterclockwise. So, and this is what we learned in the last unit, so this should not be anything new. Okay, so let's plot these points on here. And I'm going to change the color so that we know the difference. So 0, negative 1, 0, negative 1 is now going to be my f double prime. Negative 1, negative 1, negative 1, negative 1 is going to be my h double prime. And then 0, 1 is going to be my g double prime. I'm actually going to erase the blue figure because we don't need it anymore anyways. Okay. Okay, so now this is our new figure. Okay, so we have rotated it this way. Now we're going to dilate it by a scale factor of 2. So all of our sides are going to get larger by a scale factor of 2. So a way that you can do that is you can just say, you can take all of these points here and multiply the x and y by 2. Okay, so 0 times 2 is going to be 0. Negative 1 times 2 is going to be negative 2. Negative 1 times 2, negative 2, negative 2. And last point, 0, 2. Okay, and those are going to be your new points after you've dilated them. So that is one way that you can do that. I'm going to erase this figure, make it a new purple figure. So then we have 0, negative 2. Oh, let me make it a purple color. 0, negative 2. That is where f, our new f triple prime is going to be. Negative 2, negative 2. That's our h. And then lastly, 0, 2. It's going to be our g. So here you notice that we have now dilated the figure by 2. So each side has gotten twice as large. And this is your final object. And these two figures are similar to one another because they are the same shape but not the same size. Okay, thank you.